She has been serving here as a assistant professor, then associate professor, and present retired as associate professor, and presently serving as a very coveted position of UGC BSR professor in the Department of Marine Biology. That's got by very few people. Now, she has very valuable papers, several, almost finished. I think 27 to 28 PhDs have been completed in her supervision. Several of teacher students are adorning very important positions in not only in CUSAT as faculty or postdocs. They are also in and around. They are occupying several institutions. Welcome you, teacher.
Thank you so
Thank
much.
you. I welcome my colleagues of the department, Professor Hatha, Professor Anikutti. I think they will be, if they are not online, they will also join soon. My colleagues, Dr. Swapna, Dr. Priyaja, Dr. Padma Kumar, other postdocs, other research scholars of the department, my young MSc students, take this as a, because the concept of this marine biology lectures, why we devised this program for a month, you will be having at least one or maybe two lectures. Sir, we are also fortunate to have Dr. Lisa Levin. She has consented to come online webinar. She has consented, and I was just fortunate because she was from Lisa Levin is a very reputed person globally. She has been to CUSAT once under the Erudite program. So she has consented that she will come. So I have to give her our timing so that it matches with the Pacific timing. That's very important. So she will be, she works for now climate science of the United Nations. So we are fortunate. Then we will be having also Cedric Hubas. He is from the French Institute. So we have some couple of international speakers also who will be joining. So I think our students, scholars have to really get benefited, especially sir. Please take over, madam. Please, teacher, kindly take over. Thank you all so much. Have a great presentation and talk today. Please interact after the talk. Please interact, all of you. That is more important. Get everything from sir, whatever he has garnered through his experience, at least through this short lecture. Thank you all. Thank you all. Welcome.
Okay. So, good morning, Dr. V. N. Sanjeevan, Dr. Bijoy, head of the department, our faculty members, scholars and students, and all the distinguished participants who are online. So thank you so much, Dr. Bijoy, for the very good introduction of Dr. Sanjeevan, as well as kind words about me. Thank you so much. And I don't want to give more introduction of Dr. Sanjeevan right now. Already he is well known to everybody, and he's a doyen in biological oceanography, world-renowned scientist. Now, Dr. V. N. Sanjeevan will deliver a lecture on biophysical processes influencing the fishery of Southeastern Arabian Sea. Sir, I welcome you and invite you to make the presentation. Over to you, sir.
Okay. Am I audible?
Yes, very much.
Okay, very good morning to one and all. And my special thanks to Dr. Bijoy Nandan and Dr. Rosamma for having faith in me. Thank you so much.
Thank you, sir.
Coming to the presentation,
Present now, sir.
Okay, the slide is visible.
Yes, sir. Yes, sir.
Okay, thank you. My presentation, my lecture today will focus on the biological and the physical processes that promotes productivity and ultimately sustain the fishery of the oceans. Now, fish is something all of us cherish. I would perhaps correct it. Fish is something most of us will like, excepting the vegetarians, leave them alone. Otherwise, fish is something sought after by all of us. And we all know that India has a population of about 135 crores. 1 crore is around 10 million. That's around 1,350 million people live in India. And our fish production in this country, if you take the last year's fish production, it was around 13.34 million tons. 1 ton is around 1,000 kg. So we produce 13.34 million tons of fish for a population of 1,350 million. This translated into per capita consumption works out to approximately 9 kg of fish per person per year, which is far below the international standards of around 18 kg of fish consumption per year. Nevertheless, the government of India is trying to promote the fishery and the aquaculture field so that our production from the various sectors is increased. Out of this 13.42 million tons of fish produced, approximately around 3.71 million tons of fish are caught from the sea or captured from the sea, marine capture. And the remaining 9.71 million tons of fish come from inland waters, including aquaculture. So this is the quantum of fish produced per year. And today's lecture is mostly confined to the marine fishery sector. I am not going into the inland fishery, though it is producing much more. We will just concentrate to the marine fishery sector. And as and when it demands, we will diverge to the climate change scenario also. The marine fishery sector, as I told you, produces last year's fish production or fish catch from Indian waters was around 3.71 million tons. This is from an estimated maximum sustainable yield of 5.31. Recently, around 1 year back, India has revalidated its potential yield. How much maximum fish we can catch from the sea, from our sea. It is estimated as 5.31 million tons. Out of this 5.31 million tons, we are presently catching 3.71 million tons of fish. Which essentially means that most of the fish in the coastal waters are fully exploited, and whatever the balance is there are found in the distant waters on the deep sea, etc. So any enhancement, future enhancement in the fishery sector would necessarily be focused on these offshore resources. Now the fishery, the fish, I have put an equation down. Z is instantaneous mortality in fish, which is explained by fishing mortality plus natural mortality coefficients. So if we work out the growth dynamics of fishes, it all works on this principle. What we catch through gears, through nets, is the fishing mortality, and what natural mortality occurs, predation, etc., accounts for this loss. That gives you the sum total of the possible catches. Now, all these 3.71 million tons of fish which we consume every year comes from the four major ecosystems associated with the peninsular India. These four ecosystems are the Northeast Arabian Sea ecosystem, which we have abbreviated as NIAS, the Southeastern Arabian Sea ecosystem, in which the Lakshadweep Sea ecosystem also is a part of it. Then on the east coast of India, we have the Northwest Bay of Bengal ecosystem and the Southwest Bay of Bengal ecosystems. I hope all of you can see this diagram. This is the Northeast Arabian Sea ecosystem. This one is a Southeast Arabian Sea ecosystem. Deliberately, we have put a gap here. We are doubtful whether this particular region from 14° north to 17° north is an ecotone. This ecotone is the transition zone between two major ecosystems. So this is part of Maharashtra, and the full state of Goa makes up this area. We are not very sure about this. The Northwest Bay of Bengal, which includes the Bengal and the Orissa sectors, and the Southwest Bay of Bengal includes Tamil Nadu and Andhra Pradesh. Now, one thing which you have to remember, in the MSY estimations or in the catch, which I told you, 3.71 million tons of fish, the two island systems are not considered. The Andaman Nicobar is a group of islands which is our own territory. Similarly, the Lakshadweep Islands, we catch fish from there, and these two catches are not included in the MSY estimate as well as in the annual fishery catches. Now, one thing is very important. There are four major ecosystems, 1, 2, 3, 4, along the peninsular India. These four ecosystems are quite distinct or discrete in that their physical, chemical, and biological attributes are quite or significantly different. We don't have the time to go through all those things, but I will confine today to the Southeast Arabian Sea, where Kerala is part of it, Kerala, Karnataka, and part of Goa comes under this Southeast Arabian Sea ecosystems. Now, what is the role of the oceans, or what is the process? What is the role of physical processes in maintaining the fishery? That's where we are going to focus today. Some basic things before we enter into the details. We know that, like on the land, the primary producers in the oceans are tiny microscopic plants which are called the phytoplankton. I hope all of you know about it. The phytoplankton biomass in the ocean is just almost 1% of the total plant biomass which is found on land. Just 1% of that is available in the ocean. But the interesting thing is that despite the fact that the oceanic phytoplankton compose only 1% of the total biomass, it produces almost 50% of the oxygen through a photochemical reaction, which is called as photosynthesis, about which I am sure all of you know. So this is very, very important. The process of photosynthesis or a photochemical reaction wherein the atmospheric carbon dioxide is combined with water molecules to produce organic food material in the form of glucose, or such simple organic materials are produced with the release of oxygen to the atmosphere. Now, it does two vital things. One, removal of carbon dioxide, which is a greenhouse gas from the atmosphere. So it's very important. Production of oxygen and release of this oxygen to the atmosphere, and the third, it produces organic food for all those organisms which live in the oceans. So these are the three vital functions done by the process of photosynthesis by the phytoplankton, which is found in the oceans. Now, phytoplankton predominantly is, there are two predominant types of phytoplanktons. One is the diatoms, and the second one is the dinoflagellates. In addition, you may get cyanobacteria, the blue-green algae, coccolithophores are also present. Their abundance depends on particular environmental impacts. If the environment favors, they dominate. Otherwise, in normal cases, diatoms and dinoflagellates are the key primary producers of the oceans. Now, there is an alarming situation now reported from World Oceans, is that the total standing stock of phytoplankton or the chlorophyll value in the oceans is showing a decreasing trend in the last 1 decade, last 10 years or 15 years. It's showing a decreasing trend, except perhaps one or two basins. One is the Antarctica, where things are okay, and one is the Arabian Sea. Otherwise, in the world oceans, the biomass of phytoplankton or the chlorophyll concentration in the surface waters is showing a decreasing trend. What is the implication of such a decrease? It has serious implications. A decrease in phytoplankton production essentially means a decreased sequestration of carbon dioxide from the atmosphere, resulting in more and more accumulation of the greenhouse gas carbon dioxide in the atmosphere, which essentially will lead to increased warming trends. Second, most important thing is that the oxygen levels in the atmosphere is bound to decrease when there is a decrease in the phytoplankton or in the oceans, because 50% of the oxygen which we breathe are produced by these phytoplanktons. So this is something which have serious implications on mankind. Similarly, oxygen levels in the water. Normally in aquatic system, freshwater systems, the dissolved oxygen in the water ranges between 6 to 10 ml per liter, whereas in the oceans, the dissolved oxygen is less than 4 ml per liter of water. And there are many cases where the oxygen levels are coming down, even in our Indian Ocean, Indian EEZ, as well as the Southeast Arabian Sea, about which we are talking. There are instances where the dissolved oxygen levels have reduced to 0.5 ml per liter. We call it as hypoxic conditions, or in serious cases, it has gone down to 0.2 ml per liter, which normally is called the suboxia. So during suboxia, most of the organisms which occupy those areas migrate to other safer zones. So suboxia is prevalent in parts of our oceans. Now, coming to the classic food web in the ocean, as we have seen, the base of this food web is occupied by the phytoplankton, which are the primary producers. we all know sunlight, they absorb energy, they produce organic food for all living organisms found in the sea. These food produced by the phytoplanktons are first of all eaten by tiny planktonic forms, animal forms, which we call as the zooplankton. They graze on phytoplankton, they eat phytoplankton, and zooplankton in turn is eaten by smaller fishes eaten by larger fishes, birds, etc. So primary producers, primary consumers, secondary consumers, tertiary consumers. This is the classic food chain. In addition, there is another chain found in the ocean, the microbial food chain or the microbial food web, wherein the organic matter, decomposed organic matter and metabolic waste from these organisms are exported down to deeper waters. This is what is called autochthonous dissolved organic carbon, plus some amount of organic matter reaches the ocean through the river discharges, etc., allochthonous dissolved oxygen. These organic matter is acted upon by bacteria. They are degraded and the minerals are released. And this is another process which happens. This type of primary production, wherein the nutrients available in the ocean, basically like on the terrestrial plants require nutrients. Say, for example, nitrate, nitrite, phosphate, silicate, and some trace metals, zinc, etc., etc. This is required for the growth of plants. Similarly, in primary production, using these nutrients found within the system is what we call as the new production. So this accounts for the new production. Solar energies, nutrients are drawn from the system itself. Unlike this, this is what we call as regenerated production, where the organic matter is decomposed, minerals are released, these nutrients are utilized for producing carbon or producing organic material, and this is what is called new production, unlike the primary production which you get here. Or regenerated production. This is what is called regenerated production. This is the new production. And from this regenerated plants produced from this activity, flagellates will eat on this, ciliates may eat on this, and ultimately they will be eaten by zooplankton, etc., etc. So there are two key production units within the system. That's the new production using the nutrients available within the system, and second is the regenerated production, wherein the organic matter is decomposed and this is utilized for the production of more plants. Now, coming to the next thing. Now, this production, what you have seen in the ocean, is basically restricted to the mixed layer in the ocean. This is the mixed layer. This is a typical CTD plot which we have taken during our research studies. Normally what happens is that you go on board a vessel to the ocean, to the sea, and there is an instrument called CTD, Conductivity Temperature Density Profiler. The type which we are using is a scalar CTD, Seabird CTD, SB 911 plus. It's a very costly equipment. This is carefully deployed into the ocean, and this has got down here various sensors. Sensors for sensing temperature, dissolved oxygen, fluorescence, turbidity. Multiple sensors are available, and through a cable, what is sensed by these sensors are sent to the deck, to the computer on board the vessel, and we can instantaneously see the vertical profiles of temperature. Here temperature is shown in the red line, salinity in the blue line, sigma T in the black line, density of water, and chlorophyll is shown here in a green line. So you can deploy the instrument CTD to whatever depths you want. Say, suppose if you want to deploy it here, in this case, it is deployed only up to maybe 70 meters down the ocean. You can deploy it to 1,500 or up to 2,000 meters, whatever way you want. And another attraction of this instrument is that you can collect seawater from any depths. Say, for example, if you want to collect seawater from 200 meters, there is a mechanism on board the vessel whereby you can trigger this one particular rosette, and it will open and automatically collect the water thereafter it closes. Afterwards, at 500 meters, you can trigger another rosette and for collection of water. So multiple rosettes attached to this system can makes you or provides you the facility to collect water from desired depths. Then ultimately, after collection of all these things, the instrument is brought back to the deck. Now, there are a few key things as an oceanographer, as a marine biologist, you should know. The MLD, or the mixed layer depth, is the layer where there is thorough mixing of the water. The nutrient availability, the temperature, the salinity, dissolved oxygen, etc. will be same throughout this column from surface to this much. In this case, this is around 16, 17, 18, around 13, 14 meters down. MLD normally is taken as the point where the sigma T is reduced by 0.2. Sigma T refers to the density, which is represented by the black line. So whenever the sigma T is reduced by 0.2 kg per meter, we put the marking there and say that this is the base of the mixed layer. Most of the primary production which we talked about occurs here in this euphotic zone. Though the euphotic zone is not essentially restricted to this MLD, it can extend up to 80 or 90 or 120 meters down, depending on the turbidity of the water where you are working. If the water is more turbid, the euphotic zone will be shallow. If less turbid, it will be, the sunlight will go to the deeper waters. Theoretically speaking, primary production can be can happen at any place where sunlight is falling, is essential sunlight is available. But this is not true always, because in addition to sunlight, primary production requires the nutrients, nitrate, nitrite, phosphate, silicate, etc. are the key nutrients required. And the key nutrients are mostly found in the mixed layer. Definitely this mixed layer, the nutrients found there will get depleted through the process of photosynthesis, but this has to be replenished to maintain productivity. Replenishment of this happens if the bottom waters can uplift and reach this area. This is one way of doing it. Or some riverine discharge will come and supply additional nutrients. That's another possibility. If this is not possible, the available nutrients within the MLD, mixed layer depth, will get soon depleted, and the process of photosynthesis as well as primary production will start decreasing. So this is the thing about MLD, or mixed layer depth. Then there is another layer which is called isothermal layer. This is the isothermal layer starting from top, where the temperature is almost even throughout. This is the isothermal layer. Within this another strata of the ocean is the thermocline. Thermocline is another thing which starts from the base of MLD and goes up to, you see the temperature profile, and goes up to a point here at 50 where it gets stabilized. Temperature is almost same downwards. This region, the transition from this temperature gets reduced. So here it was 30, gets reduced, almost reaching 15 degree, etc., 18 degree. And this transition zone is what we call as the thermocline. This is the top of thermocline. This will be the bottom of thermocline. Okay. So the essential thing is that there is a layer here which normally is called the barrier layer between the ILD and the MLD. There is a barrier layer which is not permissible. It will not permit the nutrients from bottom to reach up. That is why most of the primary production is confined to the MLD. If just below the MLD, if there is a barrier layer, the possibility of nutrients reaching and replenishing the nutrient availability is very, very less. Okay. Now, most of the regenerative production about which I talked to you earlier, there are two ways of productivity in the ocean. One is the new production using the nutrients available within the system. And second is the regenerated production. You degrade the organic matter or metabolic waste, and using that, plants can grow. The regenerated production mostly is confined to these areas where there you can see deep chlorophyll maxima or subsurface chlorophyll maxima. If you see the float here, the green line represents that. Here, this is on the surface, this was the production, the chlorophyll content. You can see as you come downwards, it increases, then decreases. Then decreases. This is what we call as the subsurface chlorophyll maxima or the deep chlorophyll maxima, another type whereby productivity can be done. Now, after having talked to you about all these things, I will come back to the Southeast Arabian Sea ecosystem. Now, this is the western part of the Goa, Karnataka, and the state of Kerala. Together forms the Southeast Arabian Sea ecosystem. Now, this ecosystem experiences 4 seasons in a year. The season starts with the summer monsoon. This is extending from the months of June, July, August till the end of September. We call it as the summer monsoon. And we had undertaken detailed analysis of the surface primary production and the column primary production in the sea Surface primary production means the primary production confined to the surface of the oceans, normally up to a depth of 5 meters. But if the MLD, mixed layer depth, is down, last time when you had seen the plot, the MLD was just around 13 to 15 meters down. Sometimes the MLD, mixed layer depth, can go up to 120 meters down. So there will be different stratas where primary production is carried out. In that case, it is not restricted to the surface waters. The process of photosynthesis will be carried out along the depth of this extended MLD. In that case, we divide this entire water column into different strata of 10 meter, 20 meter stratas and add up all the productivity and estimate the column primary production. Okay, now coming to the first season, the most productive season or the most important season in the seas, Southeast Arabian Sea, is the summer monsoon, where the surface production is 30.87 milligram of carbon per meter cube per day. Okay, this much. This is essentially because lot of nutrients are available in the surface waters through the process of what we call as the upwelling process, about which I will discuss later. And the only thing which you have to remember, despite the fact that there is heavy load of nutrients, you should understand that the MLD is quite shallow, just 5 to 20, 30 meters. This is essentially because the deep, dense waters are brought upwards to the surface of the oceans. So the MLD gets reduced. Once the MLD is reduced, the column productivity will be proportionately reduced. Despite the fact that the surface production is very high, the column production is 510.8 milligram carbon per meter squared. Here we are not considering the depth. Length into breadth, meter, length, meter, breadth. Now depth is the base of the MLD. So these are the two processes which are active, physical processes which are active and contributing towards the very high primary production in the seas during summer monsoon. Now, fall into monsoon is a season where the winds slacken, the winds are weak. This happens in the month of October, the entire month. The winds are weak. The phytoplankton, huge biomass of phytoplankton which was produced during the summer monsoon season, could no longer be sustained. The productivity could no longer be sustained because the nutrients are depleted, and most of this phytoplankton will start decomposing and settling downwards. Together with this, it will be the metabolic waste products produced during summer monsoon. So towards the fag end of the summer monsoon season, there is a lot of export flux from the surface to the deeper waters, wherein at deeper depths or intermediate depths, these organic matters are degraded by heterotrophic bacteria acting upon them, and regenerated production happens. And if you recollect the previous plot, you have seen subsurface chlorophyll maxima or deep chlorophyll maxima. This is an area where regenerated production is intense. This is done basically by bacteria and Prochlorococcus, Synechococcus, etc. These are the things which does that. That itself is a different thing for a huge research activity. Now, one thing which you have to remember, in the days of climate change, the studies conducted by CMLRE, my colleagues, have shown that the DCM, deep chlorophyll maxima, in fact, is extending in the Arabian Sea in its magnitude, both in its horizontal and vertical distribution. Then we have the winter monsoon season starting from November and ending by the end of February. This is a season again where the southwestern winds are taken over by the northeasterlies, trade winds. This is quite weak, and the only important thing which happens here is that during this season in the Southeast Arabian Sea is that the Bay of Bengal waters will flow into the Arabian Sea. The reason being that the rate of evaporation in the Arabian Sea will be much more, as a result of which the sea level slightly goes down, and as a result the low saline Bay of Bengal waters will start flowing into the southeastern Arabian Sea, and this is where the warm pool is produced within this during this season. The conditions are not very favorable for production. The production is at the lowest ebb. Conditions are oligotrophic. If the primary production is very less and productivity is less, we call it oligotrophic waters, oligotrophic conditions. Unlike eutrophic conditions where nutrients are available, production is high, here the opposite of that happens. The same is true with the spring in the monsoon season in Southeast Arabian Sea. That extends from March till the end of May. So the productivity as compared to this surface production is dropping here as well as here. There is column production is maximum during fall in the monsoon season. I told you the reasons for that. There is a sharp decrease in column production in the monsoon and summer monsoon seasons. Now, I told you during my lecture that the process which is responsible for providing nutrients to the surface waters during summer monsoon is the upwelling process. What is upwelling? Upwelling is nothing which you need to understand one thing. The wind which is southwesterly, it comes from the southwestern side of Indian continent. Southwesterly winds, it comes, hits the India somewhere at 17 degree north near Goa, and part of this wind will flow along shore. This is what we call as the along shore component of the wind stress. This along shore component induces a sort of stress on the surface of the ocean, and because in the north, because of the Coriolis effect, the earth is rotating, there is a Coriolis effect, as a result of which this alongshore wind stress will cause a offshore transport of the surface waters. This is the wind stress coming from north to the south, from Goa to, say, for example, Kerala state. As this flow is maintained, wind flow is maintained, because the earth is rotating, there is a Coriolis effect, as a result of which the surface water from here is transported offshore. We call as the Ekman offshore transport. Okay, once the surface water is removed and pushed offshore, the water from the bottom will start uplifting. This uplifting of water and takes over the surface water. This uplifting is what is called as the upwelling process. The rate of upwelling will depend on the wind stress. The more the wind stress, the more the rate of upwelling. Upwelling index is calculated this way, where the tau divided by PWFL, where tau is the wind stress. This stands for the wind stress. PW, in fact, is the density of seawater. If it is more dense, the transport will be slightly less. If it is less dense, transport will be more. So the density is a factor concerned. F is for the Coriolis effect, and L stands for the rate of upwelling. So all this is computed, and from using this, we can produce indices for the upwelling process. Unfortunately, in India, I don't think we have an annual index for the upwelling process. This is something which we should plan in the near future. So essentially, the Southeast Arabian Sea ecosystem is an EBOOS. EBOOS means eastern boundary. We are on the eastern side of the Arabian Sea. Eastern boundary upwelling system. So SEAS is an eastern boundary upwelling system. Now, things are not as simple as I stated right now, because the wind stress exerted on the seas by the southwesterlies, the alongshore component of the southwesterly, do not have adequate force or strength to essentially explain the nutrient availability in the surface waters. This means supplementing this process is something else. And later research have documented very clearly that the process of upwelling along the southwest coast of India has several components. The entire process is supplemented by some remote forcings. Now, if you come to the tip of peninsular India, this particular part, the Cape Comorin, Kanyakumari, and the area south of Kollam to Kanyakumari sector, the winds are flowing almost tangential to the land. This is the other wind, southwesterlies normally come this way and hit here, and ultimately part of it comes here as the alongshore component of the wind stress. Okay. Now here the winds are tangential. It strikes straight to the land this way. And because of the rotation, the water from here is pushed offshore and the process of upwelling occurs here. The most intense upwelling along the southeastern Arabian Sea occurs in this particular sector. And this is 100% supported by the wind stress. Coming to the next sector, starting from Kollam almost up to Mangalore, there is a combination of forcing mechanisms. One definitely is the wind stress. Okay, the winds which are flowing this way. Second most important thing here in these arrows, we have shown coastally trapped Kelvin waves. This is a type of waves which are found deep in the ocean, 400 to 700 meters down. And these waves are generated due to the upsloping of sea water on the continent caused by trade winds. It creates pressure. Pressure is converted in the form of Kelvin waves. Kelvin waves propagate along the margin of the continents, and in this case from the east coast it passes to the west coast and it flows northward. This blue arrow indicates that. Kelvin, during the summer monsoon period, Kelvin has got an upwelling mode. Upwelling means it pushes the water upward, upwelling mode. As a result, the deep water, the water which is found at 700, 600 meters down, is brought up to 200, 300 meters. And this essentially is pumped by the process of upwelling. That is why there is a heavy nutrient load in the surface waters, despite having a wind stress which cannot account for the entire nutrient load which you get in this part. Now here, this Kelvin wave has another beautiful thing happening with that. It has an offshore extent. Part of the Kelvin, once it touches the coastal area, there is something which is called the Rossby, offshore propagating Rossby waves. These offshore propagating Rossby waves, shown in red arrows, in fact transport the deeper waters offshore. As a result, this particular sector has combinations from wind stress. The deep waters are brought up by the Kelvin, and the surface waters are transported far off to the exterior by the Rossby. That is why this particular sector is the most productive sector area-wise. Whereas when you come to the northern part, this is weak, this part is weak, and most of the upwelling is restricted to the coastal belt. This is true in the case of areas north of Mangalore. And as you reach Goa, upwelling process is almost confined to the narrow territorial waters, 12 nautical mile waters, or maximum up to the contiguous sea, that is 24 nautical miles. Okay, this explains how the nutrient availability is sustained and how maximum primary production is accounted during the summer monsoon season. Please remember, summer monsoon perhaps is the only season in the Arabian Sea which we can say is very, very productive. Definitely, most of the fishes prefer to spawn, lay their eggs during this season, because it ensures that the larvae which hatches out from those eggs get sufficient food. Yes, definitely there are some fishes which have their peak spawning season in October month also. Again, the reason there is very clear. October month is also a productive season, though it is mainly from regenerated production. So fishes have adjusted their spawning period to such times as that the moment their larvae is, the egg is hatched, the larvae comes out, the larvae sustains 1 or 2 weeks using the yolk sac. Their food are found in the yolk sac, and thereafter they start feeding. When they start feeding, they require the specific size class of food. If that is not available, they will perish. So there is an adjustment within the spawning stock to deliberately spawn in specific times within a system. Now, we have undertaken extensive studies on the availability of the eggs and larvae in the west coast of India, the seas, which are depicted in these 2-3 figures. You can see that most of the eggs are spawned in the southern part. Here. While Indian mackerel, Rasta liger also prefer to have this, and anchovies in turn, they prefer the northern side. There are specific reasons for this, for choosing these specific sites for the process of spawning. Now, we started with the fisheries and we end with the fisheries. Now, in India, the fishery is supported mostly by fast-growing fishes like oil sardines, the Indian mackerels, anchovies, etc. 50% of the catch is contributed by these 3 species: oil sardines, Sardinella longiceps, Indian mackerel, Rasta liger congerta, and anchovies. There are 10-11 species which form the anchovies. These are the three main epipelagic fishes, small pelagic fishes abundant in this ecosystem. Most of these epipelagic fishes spawn during the months of April and May, just before the onset of summer monsoon. So if it spawned during April, May in the southern sector, so mostly in this sector, the spawning process is happening here, happening at this site during April, May, so that it provides, it takes a few weeks for the eggs to hatch. Once the eggs are hatched, they will survive for another 10 days, 15 days using the yolk. Thereafter, they come into the flexion stage. The mouth will open and they will start searching for food items depending on the gape of the mouth. If the mouth is very small, they prefer to have very small food items, and their recruitment to the fishery or their entering into the adult stage or recruiting to the fishery is basically dependent on the rate of growth as well as the whether they will perish or leave or how fast they are growing. All these are dependent on food availability. So that is why it is very, very critical for these fishes to spawn at the right place at the right time. And that is done. Oil sardines mostly prefer upwelled waters near the coast. Oil sardines this way, and Rastrellium mackerels, on the other hand, prefer the spawning sites slightly far away from the coast. They're mostly offshore waters also they spawn because there are some eddies, some turbulence here, eddies here, and around the eddies also they do. Anchovies, on the other hand, do not require cold surface waters. They prefer to have even warm waters for their spawning purpose, and that is why, unlike the other two species, anchovies can spawn even in the north of Kerala or the northern segments of this sector. Okay, I think a few more things which I need to add. Now, when we are talking about the fishery, one thing which we have to remember is that next year's fishery, how much fish we will get, is dependent on the success of recruitment. By the process of recruitment, what we mean is that how many of the eggs and larvae produced during this particular year can develop, can grow into bigger juveniles and the organisms which are 6 months old. In most of these fishes, recruitment happens once they are 6 to 8 months. Recruitment means they are available in the net, commercial nets, which we use for catching the fish. So next year's fish abundance is proportional to the spawning success. To ensure spawning success, there are some criteria. Say for the onset of monsoon is a critical criteria. If the monsoon is delayed on, or if it starts much earlier, the entire natural rhythm of fishes is disturbed, and this can lead to recruitment failure. Similarly, the availability of the right type of food in the right size class to ensure their fast growth, reduce predation, is another critical factor for the recruitment success. So recruitment success is essentially based on several factors. Here the 2-3 important things which people say about clupoid fishes, about these small pelagics. which is normally found in upwelling systems like what we see in um, Southeast Arabian Sea, is that there is a window concept formulated by Curry et al. In 1989. And almost on the similar lines, there is something called as a triad concept by the Bakun et al. In 1998. These two concepts basically define the optimum conditions under which recruitment can be stable and can be successful. The three conditions are enrichment. Enrichment means the area should be enriched. Upwelling process enriches the area. The concentration, the eggs and larvae normally prefers to get concentrated at one specific sites, which we normally call as the nursery grounds. So concentration is critical to ensure the success of recruitment. Third is detention. It should be detained within that nursery ground. Sometimes if the wind is very heavy, it can cause turbulence. Turbulence, in turn, turbulent waters. In turbulent waters, these larvae and the eggs are dispersed to far off areas, far away from the nursery grounds, far away from their spawning grounds, to areas which are not suitable for optimum growth. So the fishery may collapse in that case. So this is what the three things, triad of the window concept. If any of these things, enrichment or upwelling process is extreme, then again the eggs and larvae are transported offshore, where they will perish. If there is less upwelling, again the recruitment will not be successful. There is an optimum value which is required for their success. Same is true with the process of concentration and the process of detention, which are essentially based on physical processes. Okay, this is a photo which we, I think, when we had gone to the Andamans, immediately after the 2004 tsunami, it was surprising to see that part of the natural habitat of Andaman remained intact despite the huge tsunami disturbing many areas. So what I thought I should convey to you is that the nature can protect us better than all man-made gadgets, because many gadgets have been used which have been blown away by nature, the tsunami, whereas here is a mangrove system which still is intact. Thank you so much for listening to me. Thank you so much.
Thank you, Sanjeevan sir.
Yes.
Thank you so much. And now we will have a discussion over the topic. Yeah, members, please come up with queries and questions, clarifications, please. Participants, please. Any questions? Sir, one question: will there be any shift in the spawning season based on the physical processes in the sea? You said the larvae will be affected by the physical processes. So there is a definite spawning season for these fishes. So based on these, will there be any alteration or change in the spawning season?
Okay, I think the best classic example for this is by a paper by Anthony Raja way back in the 70s, where he said oil sardines, the process of atrophication of the gonads is very high if the onset of rains are delayed. So there is a direct evidence where the fully grown gonad is reabsorbed.
Okay, okay.
Yeah.
Sir, you said for suboxic 0.2 ml per liter. For anoxic, what's the range?
Anoxic is much below that, almost nil oxygen. Anoxia. Anoxia, I doubt whether we have in Southeast Arabian Sea. Anoxia is reported from by Naqvi and et al. From the Northeast Arabian Sea. I doubt, I'm not very sure about that. I doubt whether we have anoxic conditions in.
Okay, sir.
Yes.
So in that case, the OMZ and suboxic, is it the same? OMZ and suboxic, is it same?
Not essentially. OMZ in the north is a different process. South in the seas, what we get is especially the bacterial process which consumes oxygen. There is a decrease. Whereas in the northeast, again, it is huge. Here it is not that, comparatively less. Process is same, degradation.
Okay, sir. Okay.
Teacher, there is a question, I think, teacher.
Where, sir?
On the comments box, chat box.
Can you read that, sir?
Yeah, there's a question from Abhijit, sir. You can. Please, teacher, you can read. Teacher.
Okay, I didn't see that.
Yeah, Abhijit is asking, as in the availability of nutrients driving the blooms during southwest monsoons and the competition of nutrients driving the blooms during the winter monsoon, summer monsoon and winter monsoon. So our driving factors, the nutrient availability during summer monsoon and the competition of nutrients during blooms during winter monsoon.
Okay, I think, can I answer that?
Yes, sir, please.
My understanding about this, the bloom formation in the northeastern Arabian Sea and southeastern Arabian Sea are slightly different. In the northeastern Arabian Sea, bloom formation is dominant towards the fag end of winter monsoon, and this has something to do with the process of convective mixing. Now, anyway, during this season, the fag end of the winter monsoon, most of the nutrients in the northeast Arabian Sea are utilized for the growth and propagation of blooms dominated by Noctiluca scintillans. And these surface waters depleted of nitrate starts moving southward. When it reaches Goa and Karnataka, etc., there is a chance of occurrence of cyanobacterial blooms as part of this, because they are diazotrophic. They can produce nitrate using atmospheric nitrogen. So diazotrophy dominates, and the Trichodesmium blooms extend or reach even the southwest coast of India. And there are occasional blooms of other species also, but dominant are the Noctiluca and the Trichodesmium. Thank you.
Yes, any other queries? Students, please come up with questions. Yeah. No questions? There is no doubt. No doubt.
Can I ask teacher one? It's a simple because sir, you said about this anchovies and the sardines, their recruitment. So, what is the any recent observations how this production and which is related to climate, is it seriously influencing their recruitment, especially their to the regenerated production or newer production, because that would be related to the organic production. So, and it is very much related to the upwelling process. And that will definitely trigger the presence of these or the swarming of these species. So, recent literature, does it recently provide any significant influence? Because sardine and all these are there are a few theories which put that it is migrating, sardine fishery, and it is related to the fish production, Indian fish catch also. So could you just throw some light on that?
I also thank you, Dr. Bijoy Nandan,
Yes.
for raising this question. I also have come across this hypothesis that due to climate change, the sardines are migrating north and eastwards,
Yes.
which wherever platform I used to attend, I used to oppose it. The reason behind this is there is something which is called as the McCall's hypothesis, which very clearly states that the species have a preference for some core areas. And if in this core area, if the recruitment or the success of growth is very high, and the concentration or density of the population becomes very high, the animals would prefer a less favorable condition so that they get more space and food to occupy. This is exactly what has happened in the southeast coast of India. Because if you see those figures, those were the days when the sardines catch was at the top.
Okay.
Then once that pressure came, they started moving north, they started moving east. Now the second question, all of us know, we are in the field for the last 30, 40 years, all of us know very well. We are not very sure whether the stock is the same or not. Despite the fact that there are reports that there are other stocks, 5, 6 morpho types are available. I am not very sure on that. Because morphotypes can interbreed if that is the case.
Yes.
Because I don't know whether the sardines are migrating to the east, taking a round trip around Sri Lanka, and then moving to, because the other sector, the Parkway, the Rameswaram area, we do not get much of the sardines. So whether it is my colleagues in Sri Lanka says that they don't have a sardine fishery there. Very small catches of sardines. So the concept of the West Coast sardine migrating to the East Coast, etc., should be seen with some.
Maybe it is superfluous. Okay, thank you, sir. There are few more. Thank you. There are a few comments, sir. It is our Dr. B.S. Chandrasekharan. I think you know him, sir. He's online. He's from SIBA, Institute of former chief scientist, and he is nostalgically recollecting the enchanting subject of oceanography. And it's very enchanting. Your lecture has been very nice. He has just recollected, sir. Thank you, sir. Now, Rosmin Joseph has given a suggestion. Sir, is there a pattern? Is there any pattern as in their adaptation by adjusting their spawning period to the changing climatic pattern? That's something which could you, Rosmin Joseph has asked this question. Any suggestion?
Rosmin, I think I am not the right person to answer this, but with the small knowledge I have, the spawning is a process, and spawning migration is a process induced by pheromonal activities. And definitely, as you said rightly, there will be adaptations to such climate changes or weather changes, which perhaps we are able to capture here in India itself. I have a feeling that the process of spawning
Thank you. Yes,
is
please.
Augmented to the months of April and May, very, very recently only. It is because this is happening. We need proper documentation to prove this. But there is a small feeling that there is some type of adjustment of the spawning stock with the onset of monsoons.
Thank you, sir. Thank you. And now there's another question from Vignesh Samal. Sir, he's our enthusiastic MSc student. He's asking, what is the status of deep sea fishing exploration in India as coastal stocks are near depletion? Also, is deep sea fishing pragmatic in India?
Okay. Thank you, sir. I think Vignesh, right question, asked to the wrong person. But I can, whatever I know about this, I can tell you, deep sea fishing in India is not commercially viable to the best extent I know, because there are few stocks which can be exploited, but taking into consideration their long lifespan, it is not advisable to go for commercial fishing in these on these species. But nevertheless, we can diversify. We can some of our vessels operating in the coastal waters to the offshore waters for catching the tunas, which are very abundant in the offshore waters of India, as well as the squids. There are several types of squids available, which the last potential yield committee there in IOS also, remember, we estimated around 5 lakh tons or something of the squids. 5 lakh or 10 lakhs tons of squids are available, of which less than 1 lakh ton is being exploited now. Similarly, we have the myctophid resources. This can be a very good alternative to the aquaculture feed formulation companies, because unfortunately, commercially important fish species, the juveniles especially, are being used for the preparation of fish meal. Somehow, if some of us can push these people to understand that they have the resource available, myctophytes, if they can use it to produce fish meals, it will be quite good. Thank you.
Thank you, sir.
Thank
Dr.
you.
B.S. Chandrasekharan has again added that the lecture has been very useful. And he has also asked is there some tagging experiments, especially you could do with confirm the migration of sardines along the west coast, west to east coast?
Well, sir, I don't think any tagging experiment was done in India. I am not sure about that. All the tagging experiments, IOTC, Indian Ocean Tuna Commission did some tagging on the tunas. That was some 5-6 years back, about which I am aware. As you said rightly, tagging is required. Whether this to establish whether there is some sort of migration of the sardines. I don't think CMFR, I am not sure about that.
Yes, sir. Thank you. Thank you, sir. Vignesh has just added a rejoinder to that. But if lantern fishes are exploited for feeds, won't it disturb the ecosystem?
Yes, it will disturb.
Yes, definitely. Yeah. Now, Elaine has got a question, sir. And conditions, what would be the predictable future of our fishery resources? Though many processes are natural, and strategy for sustainable preservation of fish species stock or their habitat. It's a general
natural, to answer in general terms, the future scope of the fishery sector, definitely from the wild, we have plateaued the capture potential of 5.31. We are catching around 3.71 million tons. And the additional resources whatsoever are in the offshore waters, which require specialized vessels, etc. But having said this, the future of the fisheries lies in aquaculture. It can be coastal aquaculture or it can be marine aquaculture. There are conditions put on India to declare more and more areas as marine protected areas under the CBD. That is Convention on Biological Diversity, and we are bound as a signatory to this convention. The country is bound to declare more marine protected areas, and perhaps marine protected areas permit aquaculture activities. So perhaps this is something on which we need to think, so that at least by next decade something starts happening.
Okay.
Thank you, sir.
I think there are no more questions. Okay, is it Sir Bijoy, sir?
Yes, sir. Yes, madam. Please go ahead with the conclusion.
Yeah, I will close the
Yeah.
session. Sir, it was a wonderful presentation, Sanjeevan sir. Right from the basics to the advanced level, you have explained very well. And it can be done only by an expert in the field, who have vast experience in the oceanography field. And it's great to see that both the physical as well as the biological processes you are very much familiar and you have expertise. Usually it will be either the physical process or the biological process. Here the advantage we see here is you have expertise in both, a combination of both. That is really great. And thank you so much for the very enlightening and informative talk with the physical processes in the Arabian Sea and Bay of Bengal, as well as the fishery potential in the region. And it was really very informative and useful, and I'm sure that all are benefited by the talk, the faculty members, scholars, as well as the students. Now I really recollect the past period when Sir was the director of CMLRE. So our department had a very close association with the CMLRE during that particular period. And when Sir was a director, I should say it was a wonderful period, golden period of CMLRE also. And we had a lot of projects from CMLRE coordinated by CMLRE, funded through MOES. And we received lots of support from Sanjeevan sir during the period. And sir used to sit with long or very huge pile of files, even in the late evenings in the office, calculating the budget and all the details, finalizing the budget. We have really witnessed all those things. Very dedicated person, I have to say, committed person. And very rarely we can see a head of an institution like this sitting with his own hand used to write all the details. Even one page, if we just type it, it will go more than one page. That was his writing on the paper. So just to appreciate that. So that we will get the funds released and the projects will go smoothly. We can carry out the project smoothly. Thank you very much, sir. I recollect all those things, and you tell the CMLR people in all the occasions that I get. We had a very wonderful time when sir was the director of CMLR. And I'm very happy to see that your expertise is being used by CUFOS as the proper chair. Very happy to see that, sir. And your cooperation in the future also we are welcoming. Okay, thank you, sir. Thank you so much. Thanks a lot.
Thank you so much.
Thank you. Thank you, sir. Thank you. And
Thank
so,
you. Thank you.
all the participants, all the participants.
I would like to thank all the participants also, all the faculty members, scholars, and students for your active participation and for interaction, and all other guests who have participated from other institutions. Thanks a lot. Thank you so much.
Thank you.
all.
Thank you.
We'll join for a next in the next week.
Okay.
Possibly for 1 or 2 lectures, it will come. It will be notified. Wish all of your participation. Thank you, sir, for
Yeah.
accepting.
See, when is she coming? That expert?
Maybe early next month. I will intimate specifically.
Okay.
Lisa Levins. I will.
Yeah.
We are just finalizing the dates.
Okay.
We'll inform, sir. Timing is the importance because
Yeah,
Pacific timing.
time clash.
Time clash. Yeah, so we are just finalizing. She has several commitments, but she will find time. She will be here.
So thank you, sir. Vijay sir.
Thank you. Thank you, sir. Thank you. Thank you.
Thank you.
Bye. Bye to all.
Okay.